The next problem in the lead code we are solving is longest palindromic substring. Okay. Basically, one note here is that we are not solving this problem via using dynamic programming. If you are looking for a dynamic programming solution, you can skip this video. At least for this video, we are not going through this approach for now. Okay. So let's see the problem now. Okay. So what is this problem about? Basically, longest palindromic substring, right? This problem is not about just asking like if to find out if the string is palindrome or not. Okay. So that will be a straightforward thing, but what is being asked here is longest palindromic substring. Okay, we need to look for each of the substrings and we need to find check if it is a palindrome or not. Okay, that is one thing, and we need to return the maximum, I mean the longest palindromic substring. Okay, like b a, like each of the character itself, like I mean will be palindromic, right? Like I mean if single character itself is a palindromic, so minimum length will be like always will be one, right? So we need to find out a maximum one, like which can result in the longest one, right? Okay, now let's see that how we can solve this problem. So in this problem they have given us an example of BAD, right? Before actually jumping onto the solution, right, let's try to see, like I mean how can we identify if the string is a palindrome or not, right? There are multiple approach of doing it. So let's say that we can use a two pointer approach, correct? We can use the left pointer here and right pointer here. So let's say that this left, this is right. We can compare the character. Okay, once this is done, let's say that if it is matching, so what we can do is we can move our pointer to this one, right? So what I mean is, let's say we are comparing with the Bob. Okay, we'll be initially setting our pointer to left and right. Okay, left and right. So let's say that we'll be comparing left and right. Okay, yeah, the character is matching, so we'll be moving our left pointer here and right pointer decrement. So ultimately when the left will become to right, it means that all the characters that are matched, so we can consider this as a palindrome. Okay, this is one way of doing it. The other way of for doing it is like expanding around the center. Okay, expanding from the center. Okay, so let's say that we can say uh, ABA. Okay, ABA. Okay, we'll be doing the same thing, but what we'll do is we'll identify the length. Okay, we'll identify the length or whatever it is, like we'll be starting from the center basically. Okay, we'll pick one character and we'll see that, okay, we'll set it as this itself as pointer. Okay, left will be the same and right will also be the same. Okay, and we know that each of the, like I mean each individual character is itself is a palindrome, right? So what we'll do here is, like I mean we'll here we started from the end and we started going towards center, but here we are already at the center, we need to expand it now. So what we are going to do here is we are going to decrement the left pointer. Okay, like we'll move our pointer, left pointer to here, and we'll move our right pointer to here. Okay, so once we are done, we'll be comparing it if it is a if it is matching or not. If it is not matching, we are consider it as a not a palindrome. If it matches, we'll proceed further. We'll increment, we'll move the left pointer here in this direction, right pointer in this direction. Okay, so one change here is that one we need to keep in mind here is, in ABA this is the exact center, correct? But if it is then even we need to consider the length of palindrome here basically. Like I mean let's say that this was a odd, right? Like odd, we can like I mean this is we got an exact center, but for a even we don't get an exact center here, right? We'll be considering these two as a center. So basically what will happen here, left will be this one when we start, left will be this one, right will be this one. Okay, in the odd it will be the left and right will be the same, but in even length, like the left and right will be different. Okay, like I mean just neighboring ones. Okay, this is the approach. Okay, for this problem what we are going to do here is, like I mean there are multiple ways of solving it. One is, like I mean I can simply apply the brute force, right? For each of the character I will start here. Okay, I will pick this character and I will start finding out a brute force. Okay, so basically maybe I can set a pointer from here. Okay, and I can try all the combinations. Like I mean I can set my pointer initially to here, and then if it didn't work out I will reduce it, and next time I will picking this as a start and this as a end, and once I'm done, if I not find it, I will go here. All this kind of combination that can be done here. Okay, brute forcefully we can find the solution, or you can use a dynamic programming to solve this problem. But let's see the straightforward approach. Okay, so for that, right, what we are going to do here is, let's say that what we are making one assumption is whatever the character we will pick, right? Let's say that we'll be iterating through this string from the left to right. Okay, we'll consider each of the character itself is a palindrome. Okay, we'll try to check if it is a palindrome or not. Basically we'll consider this is a center. Okay, so we'll be having a loop like that will be iterating from the left to right, and we'll be getting the character. For each of the character we'll consider it as a center. Okay, so what does it mean is, let's say that we have a BABAD, right? Currently we are at currently we are at B. Okay, currently we are at B. We are going to take this string and we are going to analyze the same. Okay, so what will happen in a BAD, right? We'll say that this is the initial index. We'll send it as a center. So once I expand to the left, expand to the right, I didn't find any of them, right? So the max length will be 1. So we'll be returning back. Okay, and we'll be also have to consider for the even length, right? Okay, let's say that to make it clear, whatever we explained right so far, like I mean that is the same principle here. It is just that we are going to consider it as a center. I will check, I will be sending asking that we will be having one common function that actually checks the palindrome, okay, for that index, like expanding and checking if it is a palindrome, and it will return as the length. Okay, so basically we'll be trying for this one. The length it will return is 1, right? Basically then next when we consider, when we go for this one, it will say that this as a center, and it will again expand it till this point, and it will return as the length. Okay, next we'll be sending this index, and it will return as this index. Okay, this range. Okay, like basically, like I mean if we check this one, right, this won't be matching, so this is what is happening. Okay, so this is the straightforward approach that we are talking about here. So basically we'll be iterating from left to right if the things are clear, right? How the expand from center is working, and what are the methods, like how to check the palindrome, right? There is nothing much to solve here basically, right? So basically we'll be traversing from left to right. For each of the index we'll be considering it as a center, and we will be analyzing it. Okay, and let's say that as we said, right, when we are using the expand from center method, we'll also have to check for center can be like I mean one digit 1, or center can be 2, right? Like let's say that if we are analyzing this for 0, right, like that will be that will be given us for the even length or odd length. Okay, but if you want to analyze for a even length, you will also have to consider the next as a center index, correct? So let's say that if it was a BB, right, BB A B C D, something like that, right? So if it is a even length, we'll have to consider this as both as a center, correct? So for that we'll see like how we are going to implement it. But we'll have to do the analysis for even length, like we'll be doing the analysis for both. Okay, so for odd length we'll be considering only this as a center. For even length we'll be considering I as well as I plus 1 as the center. Okay, now we'll see the code actually, like I mean that will be more clear. Okay, so what we are going to do here is, initially this is a like some handling some condition. Okay, let's say that if n is equal to, if string is empty or string is only one character, we don't have to proceed further, right? Like if it is, even if the string is one single character, it is the maximum palindrome that we can get, so we can simply return that. Okay, and here what we need to return is and also one more thing is here, right, BAB is also a palindrome, ABA is also palindrome of the same length. We can return either of them, one of them here. Okay, that is one thing. And also what is happening here, so and also we'll be returning the string. Okay, not the just the length, we'll also return the string here basically. So start index is equal to 0, max length will be initializing some values here. Okay, and this is the helper function for us, that will help us in expanding from the center. Okay, like I mean to check if the palindrome or not. Okay, for a given index, for a left and right. For a for a odd length, like when we are checking for a odd length, right, it will both will be the same. And for a even length, right will be one like I mean it will be greater than left, like by 1 unit. Okay, by 1 unit. And this is the algorithm to expand from center. Let me just explain you quickly. So we'll be getting a left and right pointer. Okay, so whenever there is a match, we'll be decrementing the left pointer and incrementing the right pointer. Okay, this will ensure that we are staying in the limit and we are not going behind the string indexes. Okay, this is the limitation. So basically whenever there is a match, we'll be decrementing our left pointer and right pointer. Okay, finally we need to get the length, right? Like what is the string length that actually match, because we need to compare, right? Like we need to check that which is giving us the maximum result, correct? So that's why we'll be calculating the length here, we'll be ultimately returning the length here. Okay, and also if you break down this one, right, how did we come into this solution? Okay, so basically this is a zero based index, right? So let's say that if I want to take 0 1 2 3, right, if I want to take a difference, what is the length of it, what am I going to do? Like basically usually you do right minus left, correct? But this is a zero based index, right? So we'll have to add a 1 to it, correct? So that's why n minus r minus left plus 1. Okay, plus 1 will be there. Okay, but here if we are having a minus 1, how did we come into that? So we'll see it. Okay, so basically the expression goes like this: right minus left plus 1 minus 2. Okay, so what we just saw, that plus 1, how did it come, correct? So where is it minus 2 is coming is, let's say that when you say exit this loop, right, it basically it means that the left and right are invalid at that point of time, correct? So we need to go to the last valid is like I mean 1 minus, like I mean left minus 1 and right plus 1, right? Like I mean just before like I mean performing this calculation will resulted in making the string not palindromic, correct? So that's why we'll have to subtract those two length also. Like I mean this has contributed the two more lengths, right? That has make the string not palindromic. So we'll simply have to subtract the 2 from here, right? So one is plus, we'll add a plus 1 to because this is a zero based index length calculation, and we'll subtract minus 2 because adding making this change made the string as non palindromic. We'll go one step back, okay? That's why it will be minus 2. So ultimately we'll be getting this one, okay? This is the problem for expanding from the center. And now this is the algorithm, okay? Like basically, like I mean what we're going to do here. So for each of the index, as we discussed before, we'll be picking the index, okay, and we'll expand it from the center, okay, and we'll have to do it for both odd length and even length. If it's an odd length, like both the like I will be center, right, left is equal to right every time. But for even length, right will be like one index greater than it, okay? So we'll calculate the both the length and we'll check which is giving the more result, okay? And also if it is more than the current value that we already stored, max length we are assuming it as a 1. If it is more than that, we'll be our replacing, basically we'll be updating our max length with the latest length, okay? So whatever the length that we get here, right, finally we'll be returning that string here, right? String is equal to start index to till the end, okay? And also here, right, like and also these indexes are the mid index, okay? This is not a start index, okay? We need to, like I mean, divide the whole array divided by 2, so to get the length actually, right, whatever the length that we got. And we need to step back basically, like I mean let's say that if you found a some string, right, let me select the color. If you found some string, let's say that I will say a b c d, and here we say that Bob, okay, some character, and whatever the I is equal to here, right, this is not a start index. We need to move our we need to identify our start index here. This is the start index for us because this is the palindrome, right? We know the length, so we'll divide it by 2, and to make it to work for both even and odd, we'll minus it by 1, okay? 3 minus 1 divided by 2, so we'll get this exact index, okay? And finally we can set that as a start index, okay? And finally we'll use that here to split and get return back the result. That's it. Thanks.